Hello, in this video we will practice on our limit knowledge. So in the first example we have limit as t approaches 0, some expressions here. Okay, so if we substitute 0 there for t, we'll see we have 1 over 0 minus 1 over 0, and 1 over 0 does not make sense. Okay, so for this reason we need to put them on a common denominator and do some algebraic manipulations to come up with something simpler than what we see now. So this will be limit as t approaches 0. If we multiply both numerator and denominator of the second term by root 1 plus t, we will see it will be 1 minus root 1 plus t divided by t root 1 minus t. Okay, so this is what we will have. In this sort of problems, we usually multiply both numerator and denominators of the terms by the conjugate of the irrational number or expression. So here we have 1 minus root 1 plus t, so we need to multiply both numerator and denominator by 1 plus root 1 plus t divided by 1 plus root 1 plus t. This will not change our expression at all. So this means we have limit as t approaches 0. On the top, using the identity, the difference of squares, we will end up with 1 minus 1 plus t on the top, and on the bottom we will see it is t times in root 1 plus t times 1 plus in root 1 plus t. Okay, so this t is also included in the root. Let's extend the root a little bit. Okay, now also close the parentheses. Okay, now on the top we see 1's will cancel out and we will end up with negative t. Okay, let's put it here to save some space. Limit as t approaches 0, we will have negative t divided by t times the same quantity, and this same quantity will be 1 plus t in root, and also 1 plus t in the root. These t's will cancel out. Okay, so these t's will cancel out and we will continue. Limit as t approaches 0. On the top we have negative 1. On the bottom we have the root of 1 plus t times 1 plus root 1 plus t. Okay, so this is what we really have. Okay, now if we substitute 0, can we really get anything out of this expression? Let's see. On the top we have negative 1. This is nice. On the bottom we have here, this will be 1, and this will be again 1. 1 plus 1, this will be 2. 2 times 1, it's basically 2. Okay, so this is what we have for this limit. Okay, you see, after some algebraic manipulations, we can remove some sort of difficulties that we face initially, and we can sort of find a better and easier way to find the limit values for such expressions. Okay, so next we have something similar. Again, for this problem we need to multiply both numerator and denominator by conjugate, because if you substitute x equals 0 directly, you'll see this is 0 divided by 0, and 0 divided by 0 does not make sense for us at all. Okay, so we need to multiply both numerator and denominator by the conjugate. Okay, so this limit will be limit as x approaches 0, x times 3 plus root x plus 9, okay, divided by what? 9 minus x plus 9 in parentheses, right? This is the difference of squares. Okay, so this will be limit as x approaches 0. On the top we have x times 3 plus root x plus 9, and this will be divided by, okay, on the bottom we have 9 minus x minus 9, so this 9's will cancel out and we will have negative x. Okay, again we can eliminate x values from both numerator and denominator. Doing so will eliminate all the difficulties with this problem. So we will get 3 plus root x plus 9 divided by negative 1. Okay, so now we can substitute x equals 0 in the expression. Once we do that, we will see it is basically negative 6. Okay. Next, we have something quite different than the other first two problems. So for this limit, we need to be a little bit careful and see what's really happening. So as limit t approaches negative 1, we have t plus 1 divided by absolute value of t plus 1. So if we substitute negative 1 on the top and bottom, we will see this is 0 divided by 0. Okay, so it's similar in this regard, but it will differ in the way we treat the problem. Okay, so now we see at t equals negative 1, we have an issue with this absolute value, because the absolute value will change its behavior close to 0, right? Because it's, if you're at absolute value and it's close to 0, if the number inside is greater than 0, it will be itself. If it is less than 0, then the result will be negative of the expression inside the absolute value. This is what we really have for absolute value. Okay, this is a problem for us. So to avoid this issue, we need to check the limit from the left and right and see if they coincide or not. Okay, so we will check the limit as t approaches negative 1 from, say, from the right. We will have again the same thing. Okay, now we are approaching negative 1 from the right. That means we have, again, let's put everything on the top and say t plus 1 divided by, okay, here in the absolute value, we are approaching negative 1 from the right. This means we are somewhere close to negative 0.999 whatever. Okay, so it is negative 0.9. Okay, so if you add this number to 1, you will see it's a positive number. So a positive number in absolute value can come out as itself. Okay, so this means we have basically 1, right? This will cancel out and we will end up with 1. Okay, so also for t as limit as t approaches negative 1 from the left, t plus 1 divided by absolute t plus 1. Similarly, we can rewrite all the non-problematic terms. So this will be that and t plus 1 divided by. Now let's see what happens on the denominator. So when t is approaching negative 1 from the left, it means t is somewhere like, it can be some number like negative 1.1. Okay, so it's negative 1.1 means if you add 1 to that number, it will be still negative. Okay, so if it is negative, inside the absolute value, you have something negative. So out of absolute value, it can come with a negative sign. So this will be negative t plus 1. Okay, so if we cancel these common terms from both numerator and denominator, we'll see we end up with negative here. So this will be negative 1. Okay, so now what's our conclusion? We have limit from we have the right limit at negative 1 and we have left limit at negative 1, but they don't coincide, they don't match. So whenever we see that, we say, okay, even if we have right and left limits, the limit does not exist. So limit as t approaches -1 of t plus 1 divided by absolute t plus 1 does not exist. Okay? So this was an example for not coinciding limits. Okay? That's all for limits. If you have any questions, please feel free to ask me using my email address or whatever way you choose. Bye.